to last time, I think the topic for this session is time, is it not?
That's
or
correct.
did we do that?
No. We are going to talk about time. What
Time.
time
Right.
is, and how time works in terms of biology.
Yes. Well, time. Okay, I'll start off by saying that I've done an awful lot of work on time. Um, uh, Beginning with Heidegger, the German philosopher, who is considered to have been the most important philosopher of the 20th century. And some say Wittgenstein was, but both the German. And his view on time, Heidegger's view on time, places an emphasis on what he calls ecstatic temporality. And the basis of that is that the present moment is always deeply entwined with the past moment and the future moment to come. And having read Husserl, who's Heidegger's mentor, after I read Heidegger, I discovered that Husserl's view on time was much the same. So that's one view of time that I've read about. It's probably the most in philosophy. It's certainly in modern philosophy, it's the most famous view of time. Although Heidegger did, in a way, steal it from his mentor. The other theory of time, which I recently discovered, was French philosopher Henri Bergson. His view of what he calls what does he call it again? La durée. And la durée is very interesting because it's comes from a book called what is it called? Creation. I think it's creative evolution. Yes, I think that's it.
Yeah.
We can always check that if we have to do an edit, but I think it's creative evolution. And la durée is deeply embedded in its there you go in its meaning with biology and evolutionary biology.
Right.
And Bergson basically puts Darwin to the test, as well as other philosophers of the time. And I would have to say that even having read Heidegger, Bergson's theory of time interests me the most.
Right. Yeah.
It's extremely profound, and based in biology. And when I was doing my doctorate, I did a special independent course. It was just me and the professor on time. And well, no, sorry, not on time, on evolutionary biology. And so I've been very interested in that. And something you might want to hear about is I have to get a book off the shelf, but I met Liam Middleton. That's her name. She puts forward a theory of evolutionary biology. She's from Ireland.
Yeah.
And yeah. So now the interesting thing about Niam's view of time is that it's deeply rooted in her Christian beliefs.
Right. Yeah.
So I thought that might interest you.
Yeah,
Yeah,
definitely.
yeah, it might
Definitely.
interest you to take a look at that. You can get it off of Amazon.
What was the name of that?
And yeah, let me just check. It's right
Yep.
here on my house.
Ah, okay.
Yeah. Yeah. Okay. So, see if I all alone now. Just you and me. Okay. So, yeah. The second book is Jesus and Women, which is interesting.
Yeah.
And her first book is Homo Lapsus, which is Sin, Evolution, and the God Who is Love. And that might interest you. It's she and I came. It's interesting because when I was doing my work on evolutionary biology, I came to the exactly the same conclusion that she came to in her book, which is that the alpha male who will arise in a time of extreme crisis and conflict on the planet to become the next Messiah um, is just that. He's the Messiah in a time of great crisis and yeah, just breakdown of civilization. So you might want to have a look at that. And it involves Christianity and love. Yeah, so it meshes well with our interest in yeah in spirituality.
Indeed.
Yeah,
Indeed. Thank you.
yeah. So yeah, you might want to have a look at that.
Mm.
And yeah, yeah. So there you go. I don't know what you want to add.
Yeah, I guess I would say from the physics perspective, excuse me, that time is happening all the time, right? So
Mm-hmm.
we can
Mm-hmm. Mm-hmm.
obviously the experiments that detected the cosmic microwave background is an indication of
Yes.
the time that was 13.8 billion years ago, and that is detectable today based on a specific wavelength of energy, the cosmic microwave, between 1.6 millimeter and 1.9 millimeter. So with
Okay.
that inflationary process of the universe, the initial wavelength that I'm putting forward of that kind of cosmic egg Lemaitre type model, that the initial wavelength was 4e to the negative 14 meters.
Mm-hmm. Mm-hmm.
The helium Bose-Einstein condensate singularity. And that
Yeah.
expansions led to obviously the lengthening of the wavelength to that cosmic background.
Mm-hmm.
So in a way, there's a framework of time associated with the universe.
Right.
and
Okay.
and there's also a framework of time associated with a biological being. And if you can
Right.
think in terms of if somebody has been sitting down watching TV and the
Mm-hmm.
television, the old TVs, if it was a PAL TV in New Zealand rather than NTSC in America, the PAL TV has 25 frames per second, and we see that as a moving image, right? So it's 50 fields
Right.
interlaced, so 50 hertz, 1 frame per second, so 50 frames per second is 50 hertz. And 50 hertz to
Right.
the human eye looks like a continuous stream of information, so that they're not
Mm-hmm.
individual frames of still images. They're actually motion pictures. In a sense, if you play them fast enough, the eye is deceived. And so the conscious being is deceived easily by a speed faster than a particular frequency. And so our conscious
Right.
mind is really quite slow, and it's slow for a reason.
Yeah.
Yeah, and the reason why it's slow is because it's having to process and integrate lots of information to make a coherent
Right.
reality. And so my
Right.
kind of take on that is it's kind of like the hare and the tortoise. You have
Yes.
a hare as the unconscious part of the mind that's using isotopes, that's using high energy
Okay.
physics. And then you have a conscious
Right.
part of the mind that takes the information from that isotope physics process, the energy from that, the photons of light released from that, which then gives the visual information for the conscious part of the mind to see. So there's both
Okay.
an inner workings atomic physics system, which is
Right.
giving the information to the conscious mind. And so a lot of my
Yes.
kind of scientific research has been focused around identifying the quantum location, the place where an isotope could be formed, and the place
Mm-hmm.
and the
Mm-hmm.
process involved in producing the isotope. So what I'm suggesting
Right. Right.
is that the aromatic ring, that hexagon ring shape of the dopamine neurotransmitter, is one
Right.
potential place where a single atom can be located. And it's kind of like a Faraday cage. So it protects that single atom from the external warm, wet environment. So in a sense, that
Right.
atom can be in a superposition of states. And what I mean by that is
Yeah.
it can actually be in many different isotope forms. So there's a
Right.
relationship between superposition and isotope.
Yes.
So as hydrogen has 7 different forms, it has 7
Right.
superpositions. Some other atoms
Yes.
have up to 38, 40 different isotope forms, which allow them
Yes.
different superpositions. So in a
Mm.
way, there's this kind of relationship between isotope physics, those
Yes. Yes.
superpositions
Yes.
in
Yes.
quantum mechanics, and the
Mm-hmm. Mm-hmm.
velocity energy that is produced in that atomic decay system. It has a
Right.
half-life timing, so it has time,
Okay.
in a sense, built into the atom based on its instability and its decay properties.
I see. That's
So,
interesting.
so that in
Well,
a way
there
it
was a part
provides.
there where yeah, there was a part there where you lost me completely. But what you've said in the last 5 minutes is very uh, understandable. Go ahead,
Yeah, yeah.
please.
So there is, in a sense, an atomic clock built into an atom's structure.
Right.
And we know atomic clocks keep time very well. So in our biology, our atomic clock unstable atom system is operating as the timekeepers. What they're doing is becoming stable. Those atoms are becoming stable again from an unstable state back to a stable state, and release energy in that process. So that process is timed by the clock that's built into the atom.
Yes. I see.
So that if I share a couple of images on the screen, hopefully I'll be able to convey some of this information. Okay. So start. Can you see this one?
Yeah. Okay. So
here is the hexagon ring, right? So this is really the shape of an aromatic ring that's present within a neurotransmitter dopamine. Yep. What's really interesting is the internal angle of the hexagon is 120 degrees.
Yeah.
Okay. There's 6 points of the hexagon. 6 times 120 is 720 degrees. So the electron is known as a fermion, and it has a quantum spin of -0.5, which means it has to do 2 full complete rotations. 2 times 360 degrees equals 720 degrees. So I'm saying here is a possible connection between why an electron has a spin of -0.5 and it needs to do 2 complete rotations, because actually what it's doing is a complete rotation around a hexagon ring where there's 6 nodes of 120 degrees to give the 720 degrees, the 2 rotations.
Right.
So if we take the hexagon ring and we draw lines across the ring, that first line, we obviously get an intersection in half. The second one, get another intersection and we get a cross in the middle. The third line we put across, we end up getting like a star, right? And there's an intersection of those 3 lines. If you look at that, it looks like a 3-dimensional box.
Yeah, certainly.
Yeah, so the hexagon 2-dimension flat planar surface can potentially give a 3-dimensional geometry if there was a single atom housed in its center, one atom, and there's only room for one atom. So in a way, the hexagon 2-dimensional flat plane structure gives a 3-dimensional reality.
Okay.
So that's one aspect of the hexagon in relation to the single atom. So the hexagon's acting as a Faraday cage. It's an isolated environment, which gives the isotope its timings. So it's independent of the surrounding environment. So in a way, it really has a functionality of a Faraday cage to protect the isotope. So the isotope can act in a particular way based on its half-life. Okay, I'll just show you another image. Okay, now what do I do to do the sharing? If I go stop sharing, and if I share again and I look for different image, okay. Okay, so in this one, again, it's looking at a hexagon,
Right.
And this is
Okay.
related to how the isotope is actually formed. So
Yes.
in dopamine as a neurotransmitter, it has this
Yeah.
amine functionality, the NH3 plus or the NH2. And what I'm saying
Okay.
is that
Okay.
hydrogen is being delivered into the ring to make the atom unstable. And then the hydrogen
Right.
comes out of the ring when the isotope
Uh-huh.
decays to become stable again.
Okay.
And and
I
so
see.
hydrogen with its different wavelengths of light
Excuse
can
me.
produce
Yeah.
UV light, it can produce infrared light, it can produce visible light. So in a way,
Yeah.
this process of light going in as hydrogen and then light
Mm-hmm.
coming back out again as hydrogen
Yes.
gives a way of understanding how vision is
Right.
connected to the timing of the isotope decay system that's operating in
Okay.
the hexagon ring that's in
Okay.
a 2D flat plane but looks like a three-dimensional environment.
Oh, that okay. That's good. That's because when you talked in the past, when you had talked about the decay of the dark matter and hydrogen, I really didn't have a clue as to what you were talking about. So this is
Yeah, I
there's
realize
some
I need to give something tangible for people to kind of understand what I'm trying to convey. And by
yeah,
drawing the images and then the steps involved in the processes and how that
yes,
shows
yes,
up the different components of, well, what has Einstein created? A space-time. And what I'm
yes,
developing really is an isotope physics process that gives time that's housed in a
uh-huh,
aromatic ring system that gives three-dimensional space. So in a way,
right,
this
right,
is a
right,
this is a biochemical process that gives
yes,
observation of space-time.
yes, yes. Okay, I see, I see. Okay, okay.
So we'll go one
Uh,
step further in the picture.
yeah. Okay. Okay. I'm gonna stay neutral on that
Yep,
for now. But
yep.
yeah, yeah. It's all, but it's quite fascinating. Okay.
So
So
this
keep
is
going.
really building on those parts of the picture, right?
Right.
We have the ring, and
Mm-hmm.
inside the ring we have the single atom.
Yes.
And so the single atom is becoming unstable when it receives the hydrogen. And the
Yeah.
hydrogen's coming from an infrared wavelength of light known as
Right.
the passion lines.
Okay.
So this is how I
That's
tie it
interesting.
into the passion of Christ in relation to
Right.
hydrogen, because
Yes, you did mention
hydrogen
that
is
briefly.
going in and then coming back out. So the idea of
Yes. Yes.
second coming, in a sense,
Mm-hmm.
gives a time reversal symmetry system. And I'm saying that dopamine is an isotope physics quantum machine that uses hydrogen. These are
Right. Right.
only one atom can fit in there, and it
Yes.
operates as an unstable atom when it receives hydrogen. And so
Okay.
we have the physics information of
Mm-hmm.
unstable atoms.
All
And
right.
currently in biology, we only use models for stable atoms, and we've completely disregarded the unstable atoms. And what I'm
Okay.
really saying is that animate aspect of human biology, the part
Yeah.
that's actually different from the table or the chair that gives life and meaning and
Mm-hmm. Mm-hmm.
action and emotion and experience and learning is all tied into
Yeah.
the unstable nature of these atoms housed in this ring system.
Okay. Okay. Okay.
And so
Okay.
that's why I keep talking about the importance of kind of understanding single atom physics in a way it really relates to, let's understand how isotope unstable atoms are important
Yeah.
to understanding how biology works.
Yes, 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 yes. Certainly, definitely. Well, I mean, we're in the field of biology with your work, so
Yeah.
that's totally a complete explanation of what you're trying to accomplish, and that's good.
Yeah.
Um,
Yeah. So you can kind of,
I'll have to go over that several times and get you to explain it to me again,
yeah.
because it's uh, it's totally out of my domain. I mean, I understand as you explained it. I got, perhaps 50% what you were saying.
Yeah.
Uh, Trained biologist would probably get the whole thing, but
Yeah.
uh, um, we have time. We have time. We have time
Yeah.
to discuss it. And
So when you see that the time in
yeah,
biology could be related to how an
mm,
atom releases energy from that single atom
yeah,
home. Its home is that
yeah,
that ring system.
right,
When that provides the decay gives a known amount of energy, depending on what
yeah,
particular atom it is and which particular
yeah,
isotope.
okay,
So some isotopes in their decay can release
uh-huh,
light faster than the speed of light.
yeah, yeah. You were saying that in one of your,
Yeah. So
one of our previous
that
questions.
refers to, well, it gives a shift in perception of time.
Mhm.
And so in biological in that biological setting where
Mm,
fight, fright, flee, freeze type, the that kind of reptilian brain, when it's activated,
yeah,
it can actually
hmm,
operate faster than the conscious mind. And so the conscious mind, in a way,
right,
is actually slower. And you think, well,
hmm,
evolutionary wise, the unconscious mind is actually the one doing the heavy lifting, the one that's actually doing all the controlling heartbeat, controlling breath,
right,
controlling
uh-huh.
diaphragm movement, muscle movement. It's it's
That's interesting.
that part of the mind, the isotope physics part, that's actually
Right,
doing the stuff that you don't need to think about. It's automated.
yeah,
And so
okay,
isotope physics has automated timing built into it based on the decay
hmm,
half-life.
right, okay, okay, okay. I'm following. Go ahead.
Yep. Yep. So there is this operating system
Right,
that's faster than
yeah,
consciousness.
okay,
And
okay. Let's
so
go
that
on this.
here
Let's
in
go.
the tortoise, the
Uh-huh.
isotope here is running faster than
Right,
tortoise consciousness that catches up. So the conscious experience of reality is actually in the
right,
past. And
right.
if we look at isotope decay timings, there's the
Yes.
there's the tau particle, the muon particle, and then the electron. And so the electron
Uh-huh.
is the experience of reality. The muon
Right.
the muon timing in the decay is at
Mhm.
1 e
Yeah.
to the -6 seconds, so a millionth of a second.
Yes.
And then the
Yes.
tau it's like uh, 0.1 picoseconds. So it's 1 e to the negative 13 of a second. So all of a sudden, there's like these different frames of reference. And because it's this isotope physics system that's underpinning what's happening, those different timings are sensitive to the environment. So you think about fight, flight, freeze, you know, you all of a sudden come face to face with a snake and you've just got to stay still. It's that unconscious part of the being that actually knows what to do before the conscious part realizes what's happening. So in a way, you know, athletes talk about flow state. They talk about being in the zone, and it's actually letting the unconscious part of the mind take over. And it is, in a sense, that part of our anatomy that's almost it's like it's inaccessible to the conscious mind because the conscious mind is too slow. Just like the TV, 25 frames per second, the fooling of the conscious mind is achieved by the unconscious isotope physics system.
Okay.
So framework.
Well, that's still.
I'm
gonna have to get my mind around that. But
so the hologram, the hologram created. The processes responsible for the creation of the hologram are due to the decay of the isotopes.
I see. Okay.
And now we can start to understand timings of things in people's lives.
Well, it hangs together. I mean, clearly there is a sequence of the different aspects of time that you discuss are clearly sequential and organized, logical, with logical connection. It's just that with not being about, it'll take me a week or two to wrap. I'll have to call you, and we'll talk about this.
Well, there are lots of layers to it, right? And so in a way, for me to have unlayered the system to kind of reveal what's going on behind the veil of vision has meant I had to build scientific models that really take time out of the picture. And because you know, most of science includes time in its calculations, in its process. And the way that I've kind of, I guess, devised a model that removes time from the picture is to work at a scale when essentially light stands still, that there is no motion and therefore there is no time. And so I'm working at a scale that really has no relevance to time at all. And so I've had to kind of convert time in a sense into a distance, into a velocity related to the speed of light and the expansion of the universe. So I've really kind of gone from the biological processes of creating time to build a framework that kind of removes time from the picture. And then by removing time from the picture, being able to go back and forward and look at different times, kind of like in a movie like The Matrix, where you get a still image, but then you can rotoscope around the image and you can get the different perspectives of that still image from those different points of view. So I've used the tools of the model to look at different time frames, but
Okay.
as still image, like
Okay.
a photo that takes one image and then look at it from different perspectives in order to understand the relationships.
All right, that's fascinating. I was, that really brings me back to thinking about David Bohm. Your work on that point, that last point, reminds me, not necessarily substantively, but David Bohm, the renowned. We've talked about him briefly already on the recording. On basically multi-dimensional aspects of time and also displacement of time and how it affects consciousness. Your model is well, his model was also impenetrable in its mathematical aspect, but he did manage to write a complete book, which I have. There are a few equations in it, but he did manage to translate his theory into layman's language.
Yep.
So
Takes
I
time,
think,
right? It takes a
you're
long
gonna have
time.
to.
Yeah.
It takes time. Takes a long time. It takes a long time. It does. It does. And I know that from
Hopefully
philosophy as well.
Chat GTP is going to
When
help.
you read pardon?
Hopefully Chat
Oh,
GTP.
chat. Yeah. Yeah, this whole AI thing is beginning to get pretty scary, actually.
Yeah.
Talking about that,
Yep.
we'll discuss that another time.
Yep.
Yeah. That's well, it's the diagrams are well done, and there's a clear flow of information. So for next week, what I would ask you to do is to perhaps not spend as I mean, I'll have a copy of the images and see if you can write a page even just explaining in a layman's language what you're doing.
Yep.
And or not necessarily layman's language, but someone who has at least a master's degree in either philosophy or philosophy of science. And yeah, no, it looks pretty fascinating. I mean, it's that some of the things you said would have profound impact on philosophical discussions of time.